Finally, we have two designers, Jamie Zigelbaum and Marcelo Coelho, and they have a studio just opened in New York, correct? You just moved from Boston to New York. So they're based in Cambridge and New York. And they are described as operating at the intersection of design, technology, science, and art. Their work utilizes physical, computational, and cultural materials in the service of creating new, but fundamentally human experiences. Fortunately, we have both of them here today to explore and dissect for us as a collective human experience here and now this vital and timely intersection, the subject and the locus of their work. Both designers are alumni of the MIT Media Lab, which I hope you'll talk a little bit more about to us, and have recently worked on a variety of projects for private collections, museums, and hotels. And I would like to mention that both designers are the inventors of computers, one being a paper computer, which I'd also like to hear a little bit about. And they both specialize in multidisciplinary cognitive, scientific, shape-changing, compositional, human-computer borderline milieu. And this also encompasses interactive garments and edible circuits. Let's hear about those, please. Thank you.
Hey everybody, how's everybody doing? Okay? Our presentation's like 4 hours. It's gonna be fast.
It's gonna be great.
It's gonna go by really quickly.
All right, so to start, there you go. So Jamie and I met at the Media Lab at MIT, and we both come from very different backgrounds that are like the mixed science, technology, fine arts, design. And a lot of the work that we do is really interested and concerned on this idea of getting computers out of their box and out of their screens and putting them into the physical world and combining with all the stuff that's sort of around us. Really kind of enriching these experiences that we have with computation and with information today. So we're going to show a lot of the work that we do and kind of explain to you how that happens through this work. And feel free to jump in whenever I'm talking.
Okay.
So this is a project called Dinnerware. It's kind of a bit of a crazy experiment, really trying to push the boundaries of how you can combine computers with materials. In the case, the material is food. So what I did is I created this plate that has electrodes all around it. And it's a plate that has electrodes all around it. And there are LEDs connected to those electrodes that light up on the plate. So if you put food right in the middle of it, it becomes part of the circuit. So in the process of eating with this dinnerware, you end up changing the quality of those lights. So it becomes kind of very interactive experience where the food is part of this electronic circuit. What's really interesting about this project is that it was kind of a bit of this crazy experiment. And it was really nice hearing you talk before, Marie, because what I did is I went to my kitchen as well and I brought a multimeter, which is this tool they use for measuring conductivity of materials. And I started measuring the conductivity of tomatoes and soy sauce and rice to see how they would behave electrically. And then you use that as a way to create recipes. So it's like, oh, if I combine this thing that's really conductive with this other thing, then I can get this kind of electrical property. And I'm a terrible cook. I actually totally suck at it. And I had you know that, yeah, all right. And I had a dinner at my place with the stuff, and I invited a couple of friends to come over. And it was really interesting to see how they, just by changing this very simple thing in this plate, my friends started stealing food from each other and sort of licking the plate. And then these really bizarre things, right? They totally took apart this very ritualized experience, which is eating at a table with somebody else, just by introducing this tiny little bit of technology. I don't know if you can tell very well from this image, but this is an example of the first personal computer. And by personal computer, I mean the computer that's made to be put in the home. What's really interesting about this design is that it was a computer for storing recipes. It had the worst computer interface in the world. It had a bunch of little lights and switches. But it also came with a counter, right? So you could cut vegetables and as you pull out recipes from your computer. And what's interesting about cooking is that if you look at the history, I mean, we've been cooking for thousands of years, right? Like forever, basically. And if you look at design recently, design has changed a lot. You know, like everything that we do today in design, like we use computers, we design circuit boards, make enclosures. Everything is digital in some ways. And I think that in some ways everybody is a food designer. You know, everybody cooks, everybody makes something. Even if you hate it, you've done it once in your life. And I thought it was really important to kind of explore this area a little bit, and started working on this kind of series of concept designs of this like future machines for the digital fabrication of food, trying to understand the kinds of things that you could explore if you combine digital fabrication, which is a design tool that we use today, with cooking. And these are total concept designs. These machines do not exist. But this is an example of this robotic chef, where ideally you could put any kind of edible thing that already exists into it, like a banana or a steak, and the machine can process it. So you could imagine, for instance, you could have a blur filter for a steak, right? Or cook fat in a very specific way. This is an example of a modeling machine, kind of combining a different property, or in this case, you can create the geometry of the food that you're eating and experiment with things like texture and just geometry and designs. This is another example of something else that would be interesting to try, which is to create this mixing machine, right? You can parametrically combine ingredients. So you could say, I want to make a chocolate candy, and I want to combine chocolate and strawberries. So give me every variation of 1% increment of chocolate, so I can decide which one is the one that I like. And we're missing one image here, but after this concept designs, I was like, okay, I'm going to try and see if I can make one of these machines and see if it works. And what I did is I ended up creating this tiny little guy that has this sort of chocolate extruders with walnut extruders as well. And
It was the probably first 3D printer for food that was functional. It's too bad. It's on our website if you want to look.
yeah, it's a tiny little machine, and what it does is it lets you create custom candies. And what's interesting about that is that all of a sudden you have digital control over the exact thing that you're eating, which might seem kind of weird, but it's very interesting if you start thinking about the other kinds of things you have digital control over, right? All of a sudden you can design food, you can send it to a friend over Facebook, and they can rate it, they can parametrically adapt it, send it back to you, and so on.
So where can you find these beautiful things? Are they on display anywhere? Has any one of them gone into production?
So the chocolate extruder was a prototype. Some parts of it worked really well, some parts worked terribly. It didn't last very long. There's a prototype at MIT right now. We also show the prototype around a couple different museums that are doing specific exhibitions on digital fabrication. But there are a lot of plans to like try to get that out there and see if we create a market for it and see. Food is this huge space, so you really kind of have to figure out what part of it is the one that you want to try. And building a machine like this is really complex.
And other spaces where you've gone, are you going to show us?
Yes. So in 2010, right, like Jamie and I got this award from Design Miami, and it was called the Design of the Future Award. And they came to us and they were like, hey, here's this really awesome opportunity. Build something that you think represents the future of design. And for us, is what I was trying to mention before, is the idea that computers and materials are going to get combined one day, and they're going to really sort of come out of the screen, and they're going to be able to interact with them.
And so in a lot of our work, we use contemporary materials, like as some of the things you've seen, we use software, we use electronics, we use new materials, fabrication processes, not just because we're nerds. Actually, the technology itself
I'm not a nerd.
Is not that interesting, but our entire world is now made of these materials, and it's really important to explore them and to push them into strange configurations, to explore their hidden contours so that we can understand more about what they mean for us. If you think about the amount of information we push through our minds, through interfaces, through machines, then back to other people, how these forms shape all those thoughts is super important. And one that's everywhere is the screen, the liquid crystal screen. And so this piece, 640 by 480, we took the screen and we break it apart into pixels that can exist in the body space, because liquid crystal screens are non-spatial. Everything is behind the screen. You can't touch it. The pixel is this entity, this fundamental unit of digital representation, a visual representation today. yet it makes no sense with the body. So here you can take the pixel out from the screen and play with it in a way that makes more sense physically. And this is a video that will hopefully play. This would have been a good one to show. Sorry about that.
So sorry.
Maybe we can do a dance and like interpretive dance of our videos.
Okay. Well, let's give it one more shot. Well, so the way that you can interact with the pixels is when you touch them. Maybe we have another image that we can show. When you touch them, they change color. And if you touch two, it can clone the color from one into the next. And then you can also manipulate them in aggregate with the remote control from afar, and you can paint them with colors and animations. And all of this to question and access notions of visual representation. You know, what do these screens mean in our culture and how they fit in with human experience of the 3D world?
Yeah, there's a particularly interesting thing about this project that we did, which is if you have two boxes, you can touch one of them, and if you touch a second one, you can transfer data from one to the other. So they'll synchronize their colors, which is effectively something like copy and paste, right, that you do with your computer. But in this case, you're doing it with your body. You're this kind of entity that connects two physical things, and you become the conduit of information between them. And I think, like, in general, too, like, a lot of the stuff that we do comes out from this frustration, right? That, like, in some ways, we hate computers because they're behind this glass, and that's kind of why we want to take them out and put them out in the world.
And the space for looking at visual representation is huge. I mean, why we use the type of displays we use today is not because those are the best displays in the world. There are many other ways to create dynamic visual representations. This image on the left is the subpixel array from a normal LCD screen that might be on your phone or on a computer. And this is the way that we make them. Each of these are little liquid crystal shutters with filters, and they're normally square or rectangular, but you can also do them circularly. And when you start to think about the units of color like halftone or older printing processes and how that changed the visual output, and then think about that in the digital space. So we made another piece called Resolution for a museum out west, and it's similar. It's made up of all these luminous particles, and you can manipulate them, but they pack differently, and the type of images this gives rise to is different just based on that simple difference. And you can also manipulate these in aggregate, and we spent a lot of work playing with ways that you can paint with remote controls to be able to put images into this substrate somehow.
Yeah, I mean, basically, if you have a medium that's a medium of light, we made it so you could paint it with light. So we have this infrared remote control that lets you, like, you can move the remote control in space and paint all this little box with different colors.
And so we have a few slides to show a bit of our process. Often people get a little scared by technology and think it's this thing that's outside of normal design practice or art practice. But we don't feel that way. We use this stuff very closely and intimately, and we make rapid prototypes. Here's a 3D print of one of the form studies for Resolution. We play with the forms over and over again, and we try the materials and try and make sure all the different sensory channels that are going to come from this object make sense to convey the concept.
Yeah, I think it's important too to understand that a lot of the times people look at our work and they see it and they're like, oh, this looks like an electronic product, you know, it looks like somebody could buy it from Apple or something. But they don't realize that stuff is, like, the stuff that we make is incredibly handcrafted. Like, a lot of it is really put together by hand. It's designed by hand in all its different levels. So that's kind of why it's cool to show this stuff so you understand, like, where it comes from.
And so we do this circuit board design ourselves, and here's one of our PCBs. And then this is an injection molding process for the enclosures for Resolution. And there's a couple slides missing, but we do all the assembly in-house in our studio in Cambridge. And then the last thing we want to show quickly is a new project. This is the first, I think, one of the first times we've shown it, that we're working on right now called Pulse. And in the same way that we're really interested in using contemporary materials to expose aspects of technology in our digital world, we can also use it to expose other invisible forces around us, and in this case, entrainment. And entrainment is this behavior of the physical world first noted by a Dutch physicist in the 1600s who was a clockmaker, and he invented the pendulum clock. And when he put pendulum clocks on the wall, he found that the pendulums over time would all move in phase. They would move at the same time, no matter when he started them. And the reason for this that's come to light over the years is that the clocks are equalizing shear stress through the wall, and just the small motion of each pendulum is affecting the other clocks. They're bound together. So entrainment is this property of oscillating systems to synchronize over time. And so this project is trying to expose that we're all actually kind of connected by these materials and forces in ways that we don't always see.
And what's interesting about entrainment too is that it happens both in the physical world and the biological world. And that's kind of what we're trying to combine, is really looking at how the physical things and ourselves are sort of part of the same ecology of stuff.
And it works across non-organic and organic materials. These are metronomes, and this video shows them all going into phase within about 30 seconds. But also the cardiomyocytes in your heart, the cells that make your heart beat, they use a similar process, feedback loops, in order to beat together. And people's voices in conversation, the frequencies will entrain. Many cycles of people in the organic world around us will synchronize like this. So we've made these 3 towers, and they all light up. And we're working on a room scale installation with the Creators Project that'll debut next year. And all of these towers have their own internal respiration. They're kind of breathing with light by the light pulsing up and down. And then once the people go into this space, here's an early lighting study of one of the towers. They start to sense you, and as you get closer to them, they react. And then if you touch it, it takes your heart rate in about 2 seconds, and then it entrains automatically with your body's cycles. And then that spreads out through the room as a kind of subtle color change, which then interacts with the other people in the room, kind of bringing everyone into this phase lock over time.
And then where do you see all that going once everyone has been accepted and entrained, and then everyone is harmonizing? Then what?
Well, hopefully that'll show, hopefully you'll be able to experience this invisible force in a way that you might not have before.
So you could create world peace, for instance.
That's the main goal.
That's the idea.
We'd have to make a really big installation for that.
Well, we can start here in the tent, actually.
But it's amazing that using one of the things that interactive technologies in particular allow you to do, as opposed to looking at static representations, is create experiences that unfold over time, and they're behaviors. And rather than representing a notion, you could write about entrainment, we can actually present it firsthand, so you experience entrainment directly through these materials that we have.
And do you have any practical applications in mind, at the university level or at the psychological kind of field level?
No.
No, really.
Not yet. It has great potential, wouldn't you agree?
Well, I mean, it's strange you ask that question too, because I did an undergrad in fine arts, right, and eventually ended up finding myself like at MIT, and that question gets asked at MIT a lot. Like people come to me, they're like, why are you doing this? What is it for? Is it patentable? But a lot of the times you have to say, I don't care, and you make it, and then people see and they experience it. And when they experience it, they see something else that they hadn't seen before, and they understand why you've made it and why it's important. So even though you can't articulate a problem that you're solving with it, you're kind of more creating an idea and a way of thinking and talking about things.
Well, and this is at the crux of Be Open's mission, it would seem. Bring it, and then let's see what happens, and let's see where we go from here. Sorry, what were you going to say?
I was just going to add on to what Marcelo was saying, is that it's important to make things that aren't going to be used for practical applications. I mean, the purpose of this work is to communicate these ideas and experiences. It's an artwork, it's design work, it's conceptual. And rather than take that and then try and productize it, I think that we can communicate better through focusing on that part of the work. And maybe, hopefully, as I have I spent years doing next generation interface design and for, working at a startup and trying to make products to change the world. And I was inspired in a lot of that through the art that I had seen and through the books that I'd read. And hopefully that's the type of impact a project like this would be our goal to have.
I completely understand and also admire the open-endedness of what you present, but I can't help but leaping, to this idea of at a corporate meeting or at a diplomatic meeting or something that everyone can be harmonized as such, So please keep going. And what were you going to say?
Oh no, I was going to say that I think what's fascinating about the work that we do, that fascinates us about it, is that it doesn't matter how hard we try to understand how this stuff is going to be used, we never know what's going to happen. And a lot of the times it's like very particular kinds of behaviors emerge that you didn't quite predict. And we're curious to see what's going to happen with this project, right? Like once you sort of put your heart rate into this tower and you start synchronizing with somebody else, how is that going to affect your relationship with them? And it might turn out that might not be in a good way, or it might turn out to be an amazing way. And
or a completely unexpected way.
yeah, exactly.
Always. There's always unexpected results.
It's so abstruse for someone like me who comes more from the creative world, and it sounds like you do too. I'm just wondering at MIT how they supported you and kind of escorted you into a place like this in the Media Lab. Can you talk to that a little?
Yeah, so I don't know if you know or if the audience knows about the Media Lab and how it works, but the Media Lab is it's a lab and a kind of a department at MIT that's made out of all these different research groups. There are about 30 different research groups in all these different areas, covering every kind of part of knowledge you can think of.
And which department, sorry?
It's part of the Department of Architecture. But then it's kind of its own like separate lab. So there's people doing like neuroscience work or like engineering and computer science and like
A little bit of design. John Maito was a professor there for years.
and so you kind of throw everybody into this place and get them to work together, and so then you get a scientist hanging out with an artist or a designer, kind of encountering the same things and start talking about projects and doing classes together, and that's where a lot of the work kind of emerges. So at the Media Lab, it's really interesting. Like in particular for me, I don't know for you, but like when I came in from fine arts, and it was like, what am I doing at MIT? I should not be here. Like I have no idea what these people are talking about. And very quickly you actually realize that you're extremely valuable, because you can look at something and say, hey, you should look at this through this entirely different lens. You're going to see something very different that you're not seeing right now. And that was something that I really learned like in art school, and I could bring in.
Well, and exactly on that note, I think that is a summarization of exactly what we've been talking about here today through all the various disciplines. And I want to thank everyone very much for being here, as a matter of fact, and to Jamie and Marcelo, thank you very much.
Thank you for having us.
Thanks.
Just a couple of concluding remarks. We are launching really a year-long series of events that Be Open is sponsoring, and this journey through the senses that they describe is really going to be once again very active at Milan Design Week in April. Specifically around a temporary installation built inside an historical courtyard at the University Statale, where different designers will be presented to express their views on sensory design. And in addition to the installation, there will be other events at the Design Week, interactive events, once again planned to explore also the technological side of the senses that we've talked about today in great detail, and to involve visitors there in multisensorial personal experience. And also there will be talks in Milan, sponsored by Be Open, but also the next one in Mumbai, where there is going to be a design week in March, then Milan in April, then in London, and then in Tokyo. So please stay tuned and follow this incredible voyage. And once again, thank you to everyone here, to the designers, to Alexandra Cunningham for convening these fascinating creatures. And thank you very much for showing up. Thanks. Bye-bye.